Welcome to Electronics Techie. So in this video we discuss about multiplexer. So in that multiplexer also there is a 2x1 multiplexer. So multiplexer is a combinational circuit. So you can give multiple inputs and you can generate the single output. So by giving multiple inputs we generate the single output. So we can give I1, I2 and so on up to IN. So like that we can give multiple inputs and we get the single output. So multiplexer is a combinational circuit. It gives multiple inputs and get the single output. So multiple outputs is also 2 power 1. So n is nothing but 1, 2, 3 and so on and like that. So that means 2 power 1 is nothing but 2 inputs, 4 inputs, 8 like that, 16 inputs. So like that you can give inputs like 2, 4, 8, 10, but the output will be the single. So here in this video, so the Verilog code is about only the 2x1 mux. So in our upcoming videos you can go to how you design 4x1 and 8x1 mux like that also. So till now we are going to look at the 2x1 mux. The block diagram is like this. So it is a 1 mux. So 2x1 mux. So they are the two inputs and the single output. So I consider this as A, B are the inputs and my output is like Y. So it is our select line. So select line means by at a time we can only select either this input or this input. So only single output, either this input or this input. So how you can get either this or this? By using this select line. By using this select line, you can select either of one of the input like that. So that's why we use this select line. So what is the combination here? So if select line means one bit means how many combinations you get? So 0 or 1. So if the value is 0, then I0 will be selected. If one S value is 0, then I0 will be going to select. If S value is equal to 1, then I1 is going to be select. Means if S is equal to 0, then I0 Y is equal to I0. If S is equal to 1, then Y is equal to I1. So like that we can going to do. So now we are going to do the design code of the Verilog, in Verilog. So it starts with module and end with one module. So it is like module name. We can give any name. Here I consider like this. So what are our inputs? A, B and our select line, and output will be the Y. So why you write reg means when you are using always block or initial block, you should be write the reg data type. Every time we discuss about that. So while you are going to using the always block or initial block, we are going to use that variable. So what is the variable we are going to use? Means in LHS side. So what are the variable you want to assign in the always block? That should be in the reg data type only. So that's why I represent Y as reg data type. So always is nothing but every time. So every time you want to depend on this variable. So what is the variable? So what you are giving in the sensitivity list. So these all are we discussed in the previous videos. If you don't watch, then go to them. So sensitivity list. So always block is nothing but it execute every time. When it is going to execute only certain number of times when the variables which are inside these braces will be going to change, then only the always block will going to execute. So here I represent a star. So what is a star? So in sensitivity list, if you represent these braces is said to be sensitivity list. So inside this sensitivity list, if you represent a star means so all inputs. So all inputs are represented by star. So if you particularly write A, so when you are going to change the A value, then only the inside values are going to execute. Otherwise they don't going to execute. If you give star means the whole input. So what are our inputs? A, B, select line. So if any change in A, B and select line, if any change in any one of the input also, it's going to be executed. So no change in these three values, then not going to be executed. So always block is like that. So if it is a multiple statement, then you are going to use begin and end statements and keywords. So if select line is equal to 0 means if select line means here in Verilog, if you write like this, it means it is a true. So if it is true, so select line is true, then Y is equal to B. Else means S is equal to 0 means so Y is going to assign Y. Sorry, A is going to assign to the 1. So end and end module like that. Here what you are writing means, so if select line is equal to 1, Y is equal to B. If select line is equal to 0, Y is equal to A. So this is the we are going to execute in this design code. So next we are going to the another, there is so many styles and while you are writing the code. So I represent every style here in a single video. So try to understand in different models. It is a like behavioral modeling. So now we are going to a gate level modeling. So for gate level modeling what you want, so whatever the gates we need, just simply write that. So for module, so what we are going to write module after module name. So it is our module name. So what is our input? So here I represent AB and select line. Here I represent with D0, D1 and select line like that. So output will be the out. So I represent output as out. So now I consider the two wires. So for while you are going to connect, so we have to write two wires. So here we use AND gate. So AND gate is nothing but, so what is our inputs for AND gate? So W1 means one wire is going to assign. Sorry. So while you are writing like that, so the output will be the W1. So for how you write the gate level modeling, first the primitive name, and again you are going to write the instance name and the port list, first input followed by the first output followed by the inputs. So first we can write outputs and then followed by inputs. So what is our output for AND gate? So it is our W1 and D0 is our output and select line is our another input. So for second AND gate, what is the inputs? So D1 and the NOT gate of, so output will be the W2. So how the representation is like this. So wait, I draw here. So try to understand the diagram. So it is our D0 input and D0 and D1 are the inputs. So there is a one select line. So these are our inputs. So first I draw the gate level block diagram, schematic diagram. Then you are easy to write the code. So I take the two input AND gate. So this select line is going to do and W1 will be our output. So again this S0 will going to NOT operation and these are the input to the AND gate. So W2. So now what you are going to do, so these values are to be OR operation here and the final you get the output. So it is our gate level modeling. So now what you have to do, first you have to AND operated two times and then you can OR operated the resultant outputs of 2. So now you can do here. So first we can take AND operation followed by instance name. A1 is our instance name. So W1 comma D0. So W1 is our output of the, so it is not to be stored. We just simply drive the output of the AND gate to input to the OR gate. So simply write it as a white data type here. So W1 is our output and D0 and S is our inputs to this gate. So you simply write the inputs here, W1 comma D0 comma S. So for second, what is the output second AND gate? So W2 be the output and what are the inputs? D1 and NOT operation of S. So you already know NOT operation is represented like this. So you can negotiation symbol with S and then end the line. So what you can done in the OR operation, the outputs of the two AND gates are going to input to the OR gate and OR operator will be a final output. So we can simply write the output means out. So W1 comma W2 is our inputs. So outputs followed by inputs. In gate level modeling, outputs are followed by inputs. First we have to write the primitive names. So again followed by instance name and then you can write the outputs followed by the inputs. So it AND module. So it is one type of gate level modeling. It is a one type of modeling style. Next we are going to do the another modeling style. So it is nothing but our data flow modeling using ternary operator or conditional operator. So it is a very simple one among all these. So you can start with module and end with AND module. So it is our module name Mux 221 like that. So it is our module name. So inputs, what are the inputs? A, B and select lines are our input and output will be the Y. So you can take a Mux and AB are the inputs and Y is the output here for this one. So what you are going to do with the select line, SCL means select line. So select line is equal to, means if select line is equal to true, what I say, if simply write the variable inside simply write the inside the braces or simply write means it is like true value. So if it is false means then simply write the negotiation or like that. So if it is true, the value will be the A. So if select value is equal to 1, then Y is equal to A. So you can write like the code. So if it is true, the output will be the A. So if it is false, the output will be the B. So you can write like this. So and end with AND module. So already this ternary operator and styles of modeling we are discussed in the other video. If you don't watch them, then go to that videos. Then it is easy to understand while you are using always keyword and sensitivity list and ternary operators. It is easy to understand while you are go through the operator concepts also. So for this is the different types of modeling styles I try. So for this code only I write the test bench. So you can use same test bench for every module, but you can change the module name here. So here you can observe Mux underscore, always there is a module name. So here you can change the module name. So here I write test bench for this module. If you want to write the test bench for this module, you can simply write this module name. Otherwise you can simply write this module name for this module test bench. So otherwise same. Start with AND module and end with AND module. So you can write module name for test bench also. So it is our module name and inputs are in reg data type, outputs are in white data type. So you can write a module name of design code. So which design code you want to design. So for that design code you want to write the name here, means module name. You can write and instantiate that code here. So Teju is our instance name. You can use any name. So it is our port connection. So port connection by name. If you are if you are familiar with order also, you can go through that. You can do like that also. Simply write A comma B comma SCL comma Y. You can simply write like this also in this port list place. So it is more convenient when there is a single sum of the inputs and outputs like that. So next we are going to assign the values for the inputs. So how we are going to assign the input values? By using initial block. So you can write initial block, and if there is a multiple statement, you start with begin and end with end keyword. So you can do different combinations for A value and B value like that. And select value means if select value is equal to 0, you are going to assign the, if select value is equal to 1, then you are going to assign B value. If select line is equal to 0, you are going to assign the A value to the 1. So like that we can write a different combinations here and finish with finish keyword by stop the simulation by using finish keyword. So first stop the simulation like that. So for these 4 lines we are using PDA playground. For generating waveform, we are going to use these 4 lines to generate the waveform and end with end module. So it is our design code and test bench code. If any problem about these 3 modeling styles, you are asked me about the particular one in comment section. I definitely make a separate video on this particular modeling style or particular line also. So no need to hesitate about asking any single line also. Means if of cell. So what is if of cell? You don't understand. So if of cell is nothing but if select line is equal to true. So if select line is equal to true, then the value is assigned going to be y. So like that, if single line also, if you are confusion, then try to comment it. So I try my level best. So it is our final output waveform. So for what modeling style I write a test bench means, so for this one. So here you can observe select line is equal to 1. So I simply write if select line is equal to 1, the output y is equal to b. If select line is equal to 0, the output y is equal to a. So here you can observe the a value is equal to 0 and the b value is equal to 1. So select line is equal to 0. So select line 0 means what is our output? So here you can observe y is equal to a. So what is the a value? It is going to assign to the y. So here you can observe, so select line 0, the a value will going to assign to the y. So here in this line you can observe the a value is equal to 1 and the b value is equal to 0. So our select line will be again 0. So select line 0 means what you are going to do? You assign the a value to y. So what is our a value? 1. So here you can observe the y value will be 1. So here we can observe the waveform. So here again you can see a value is equal to 1, b value is equal to 0 and the select line value is equal to 1. So here the select line value is going to up, so it is 1. So select line is equal to 1 means y value is equal to b. So b value is assigned to y. So y value is going to 0. So here you can observe the y value is 0. Like that you can cross check the whether your waveform is correct or not, like that. So this is our 2x1 Mux code. If you have any doubts, you can comment it. And thanks for watching. Until then, bye.